Now next topic, that is motion of center of mass. See here, we already discussed about the position of the center of mass and the position vector for the center of mass of the body having n particles or system having n particles, that is RCM equal to M1R1 plus M2R2 up to MnRn upon capital M, where capital M, that is the total mass of the system. Now take this capital M on left hand side. Therefore M vector RCM, that is M1R1 plus M2R2 up to MnRn. Now here M1, M2, M3 up to Mn are the masses of the constituent particles, and R1, R2, R3 up to Rn vectors are their respective position vectors. Now here, by considering the masses of the constituent particles as a constant, let's differentiate this equation with respect to time t. So we can write capital M drCm by dt on left hand side, that is equal to M1 dr1 by dt plus M2 dr2 by dt plus up to Mn drn by dt. Now differentiation of the position with respect to time t will give you the velocity. So drCm by dt will give you the velocity of the center of mass. dr1 by dt will give you the velocity of particle number 1. dr2 by dt, that is the velocity of particle number 2. Like that drn by dt, that is the velocity of particle number n. So we can write the equation MVCM equal to M1 V1 plus M2 V2 up to Mn Vn. Now take this M on right hand side. So we will get the equation for the velocity of the center of mass of a system, that is VCM equal to M1 V1 plus M2 V2 up to Mn Vn upon capital M. Now here VCM, that is the velocity of center of mass, we already discussed, and V1, V2, V3 are the velocities of the individual constituent particles. Okay. Now from this equation MVCM equal to M1 V1 plus M2 V2 up to Mn Vn. Now we can write M1 V1 mass into velocity, that is linear momentum. So M1 V1, that is the linear momentum of particle number 1, so P1. M2 V2, that is P2 up to Mn Vn, that is Pn. Now the summation of the linear momentas of each and every constituent particles here on right hand side, see. So vector sum of the linear momentas of each and every constituent particle will give you the total linear momentum of a system of particles. Let's represent it with P. So we can write M VCM equal to P, that is P1 plus P2 plus P3 up to Pn. Okay. Now see here, this one is the total linear momentum of a system of particles, and P1, P2, P3 up to Pn are the individual linear momentas of the constituent particles. Now see here the result. The total linear momentum of a system of particles, that is equal to the product of mass of the system and velocity of the center of mass of the system. See, actually when we discuss the definition of linear momentum, we say this thing: linear momentum of a particle, that is equal to mass of the particle into velocity of the particle. Here total linear momentum of the system equal to total mass of the system into velocity of the system is not appearing, but VCM, that is the velocity of center of mass of the system. It implies that Now here you can understand the importance of center of mass of the system. Now here you can understand the center of mass of the system itself behave as a system. Or in other words, we can say center of mass of the system, that is the representative of the system. Clear to all of you?